Hey scholars, welcome to part 2 of today's concept development. I'm really excited to work with you on this. I miss you, so it's just nice to get to kind of talk to you this way, even though it's not the same at all. But please do come to me during office hours if you have any questions. If you can't make office hours, find another time. You can reach out. I'm here, all right? So this is part 2, right? Part B, if you will. So we already did part A. Please go ahead and check the video for that before you come to part B, because we're going to be building off of what we did in part A for part B, right? So part A asked us to find the area of the smaller square that Fred cut, right, this green one, and we did that. So part B is asking us, well, what's the area of the remaining paper? So in other words, what it wants us to do is it wants us to find what's this gray area, right? And this gray area, it looks kind of funky because it's not a perfect square, right? It's like almost like a really blocky C, right? It's missing this part. And so the question that we have to answer is, how are we going to find the area of something that looks this weird? There's a hint in the wording of this, right? Which is, what is the area of the remaining paper? Normally, if I have something remaining, right, that's like I have 10 apples and I take 3 away. What are the remaining apples, right? So remaining a lot of times means we're subtracting or we're taking something away, right? And in this case, we took away the green, right? So if I imagine for just a moment that I didn't take away that green, that this was still filled in gray, right? Would I be able to find the area of the whole square? Well, yeah, I could, because I could find the area by just doing my normal multiplication, 9 3/4 times 9 3/4, right? The area of the whole thing, and I'm talking the whole thing, right? Including, actually, let me keep that there. The whole gray, right? The area of the whole pink square, if you will, is going to be 9 3/4 times 9 3 9 3/4, right? So if I could find the whole area, then what would I need to take away in order to find just the gray area, just the original gray area? Let's sort of color it like this. Let's do, right, if I needed to find this, could I take away, and I noticed that this is frozen, so give me a moment. We back. All right. Could I take away the green square? If I took this away, would I be able to find the area of this? And the answer is yes, right? Because what I'm doing is I'm finding everything, and then I'm just taking this, which I already know, by the way. I know the area of this is, let me write it in, because we found it in part A. I know that this area is 10 9/16. So if I were able to find everything and then just subtract 10 9/16, I would know the area of the gray, or the leftover, the remaining paper. So let's do that. Let's find the area of the entire square, including this area here. So 9 3/4 times 9 3/4, what I'll do, I'm going to do it in my pink so we keep our colors consistent. Move this down a little bit. Then 9 3/4 times 9 3/4. 9 times 9 is 81. 9 times 3/4, well, that's 3/4 9 times. Let's think about that. This time I'm going to do 9 times 3/4. We could think about there being a 1 under here if that helps you. 9 times 3 is 27 over 4. So I'll do that here, 27 over 4. And I have that here as well, the same one, so I know I'll get the same answer, 27 over 4. And then finally, 3/4 times 3/4, 9 times 3 times 3 is 9, 4 times 4 is 16. So similar to what I did earlier, where I kind of kept my whole number to the side while I worked with my fractions, I'm going to do that here as well, where I'm going to add 27/4 and 27/4. I'm going to leave this out for now. I'll bring it back in later. So I'm going to do 27/4 plus 27/4 first, because those have the same denominator already. So I don't have to change anything for them. 27/4 plus 27/4 is going to, fourths will stay the same, and then I just need to do 27 plus 27. I'll do that over here really quickly. 27 plus 27. I could also do 27 times 2, if that's what you prefer. 7 plus 7 is 14. 2 plus 2 is 4, plus 1 is 5. 54. All right, so now I've got this set up. Now I used my 27/4 and my 27/4. And one thing I want you to notice that I do is as I'm working through things, I cross them out so I know I already used them and I'm not going to accidentally use them again. And I circle things I need to keep in my brain for later. You can do this on scholar paper as well, right? So now I've got my 54/4, which I got from adding my two 27/4, which is why I crossed them out. And now I need to add it to 9/16. And when I do this, again, because I have 4 into 16, we talked about this actually during part A, so you can go back and find out, but I'm going to turn my 4 into 16ths by multiplying it by 4. That way I have the same denominator. And then 54, I have to do 54 times 4. I'll do that over here. 54 times 4. 4 times 4 is 16. 4 times 5 is 20, plus 1, carry the 1. 216 sixteenths. That is a lot of sixteenths that I have to deal with right there. So now I've used this as well. So now I've got, I'm going to just take this out of the way for a little bit so we can kind of see everything we've got going on. But now I've used everything but the 81. But before I bring the 81 in, I want to do something with this 216 sixteenths because that's clearly more than one whole, and I want to make sure that I'm using that correctly, right? I want to say I don't want to add, now I could add 81 and 216 sixteenths, but I'd rather break my 216 sixteenths into sort of something that's a little bit more, something easier to deal with, right? So I'm going to use my standard algorithm, and I'm going to say 16 goes into 2 0 times, because remember, by the way, this is another form of division, right? This is just division another way, so I can turn it into this. And if you're confused about that, come see me. I miss you. I'd love to talk to you about why we do that, all right? 0 times 16 is, ooh, not what I wanted. What is this? 0 times 16 is 0, as anything times 16 times 0 is 0, 2 minus 0 is 0, is 2, ooh, bring the 1 down. 16 goes into 21, 1 time, 1 times 16 is 16. 21 minus 16 is 5, bring the 6 down, woo, too big. 16 goes into 56, let's say 16, 32, right? 16 plus 16 is 32. 16 plus 32 would be 48. All right, so it'll go in 3 times. 3 times 16 is 48. And I'm going to take away 6. I'm going to have 6 left over. So it's 13, and then what's left over? 6, so it's 6 out of 16. We ended up with 6 out of 16. Now, the reason we did that, by the way, in case you're curious, is because we had 6 left over, and since we're breaking it into groups of 6, what we're saying is that we had 6 left over out of what would have been a group of 16, right? So anyway, all of this is to say that what we end up with, this, by the way, the 216 over 16, that's when I took this, this, and this, and I added them all together. Hi, Stokes. So now what we have is a cat. And in addition to that cat, we have 13 and 6/16 plus 81. Now, a reminder that that is all of the pink square, right? That's the entire pink square, including the green. So the area of the whole thing is 81 plus 13 would be 94. And 6/16. That's the area of the whole pink. But then, I am not done. It's asking for the area of the remaining paper, as in the paper after I take out the little square, or the 10 and 9/16. So now I need to subtract 10 and 9/16 from 94 and 6/16. Now, I can subtract 94 minus 10, and I'll get 84. I still need to subtract 6/16 minus 9/16, and I'm going to do that over here for a reason, which, if you'll notice, I cannot take 9 away from 6. I can't do that, right? Or I could, but I'd end up with a negative number, which is not what I'm looking for here. So what I need to do is I need to take this 84, and I need to turn it into 83 plus 16/16. Now the reason that I'm going to do that is that's still 84, right? Because 16/16 is the same as one whole. But now I can use this 16/16 and I'm going to add it to the 6/16. So in other words, what I did was I took 84, I broke it into 83 and 1. I took the 1 and I separated it into 16/16. It just changed the format of it. Now I'm going to add that 6/16 to this. 16/16 plus 6/16 would be 16 plus 6 would be 22. So now it's going to be 22/16, right? And I just now used this 16/16. All right. Look who's back. She loves area. All right, so now I know how to do this. 22 minus 9 is going to be 13. And we keep our denominator the same. So what I end up with is 83 and 13/16. Was that a lot of work? Absolutely. Can we break it down into individual steps so that we're able to figure it out? Also, 100% yes, we can. All right? So, like I said, I know it's a lot. There's a reason I broke this into 2 separate videos for you to work on. If you have any questions, please come see me. All right, we're actually going to probably talk about this on Friday when we do our Kahoot. And I want to reserve some time on Friday to just talk about it, just answer any questions you have. So I'm going to ask that you all look at this video, try this exit ticket before we get to class on Friday so that we have the time to work it out. All right, bye scholars, I love you, I miss you, and I'll see you soon.